We're starting a brand new chapter, chapter 5, which is all about ratios and ratio tables. There's a few things that I want you to go ahead and write down, so copy this slide into your notes for me. The first word we're going to talk about today is a ratio. Guys, what's a ratio?
Comparison of two quantities.
Okay, a comparison of two quantities or numbers. Okay, so it's basically where you're comparing two things together. There's 3 different ways to write a ratio. The first one, what's it say? A to B. The next one looks like A colon B, and then the third one looks like A over B. Each of these are read the same exact way, though. The first one says A to B. Guess how I'm going to read this right here? A to B. And guess how I'm also going to read this? A to B. So we're just comparing the two, one to the other. Now read me what this final thing up here says. A ratio is basically dividing the first quantity by the second quantity. Something I saw yesterday on your tests, which I want you to really understand what this means. Many of you had a problem like this on your test where it says 12 divided by 4. But when people plugged it into their calculators, guess what they did? 4 divided by 12. I want you to understand, this does not mean that we are comparing the second quantity on the bottom to the top. This is not how that should be. The first number is what you write first, 12 divided by 4. Does everybody understand that? So right here, a ratio is just basically dividing the first quantity by the second quantity. Looking at this first one, it tells us that you make flubber using the ingredients in the table. Has anyone here ever made something in the kitchen before? Some kind of a recipe, whether it's cookies or brownies, and there's an ingredient list, right? Well, this flubber has an ingredient list. What are the 4 items that I need to make flubber, class? Cold water, hot water, glue, and borax. So, in this, I am not comparing all of those things. It tells me specifically what I'm comparing. What 2 things am I comparing in this problem? Okay, the instructions ask me just to write the ratio of cold water to glue. So I am going to be focusing over here, the cold water to glue. I don't need any of this stuff right here, so you don't need to focus on those 2 other items. We're just going to focus on the cold water to glue. So first up, it asks us to write a ratio of cold water to glue. We're going to write it 3 different ways, the 3 different ways that I just taught you how to do it. How much cold water do I need, class?
3 and 2 cups.
3 halves cups, okay? So 3 over 2. And then we use the word 2, okay? That's the first way that you could write that. Go ahead and box that in. Who can explain to me how I would write it the second way using the colon? Jana, what would I do? Okay, 3 halves to 2. Once again, it's read the same exact way. Box that in because that's another way that we could write it. Who can explain to me how I would write the last one? What would I do?
Would it be 2 and 2/3?
You're always going to start. So here's the thing right here. If it says compare cold water to glue, you're always going to put the cold water first and the glue second. So how much cold water do I have?
2/3. 3 over 2.
3 halves. And we're making a what? A fraction bar. So we're going to put it over, what's the other number I'm comparing it to?
2.
A 2, okay? So notice, that might have been a little big, all right? But it's 3 halves to 2. Now, does that look complicated?
No.
It looks a little complicated because I have a fraction in there on top of a fraction, okay? But that's okay. That still means 3 halves to 2. Next up, it asks me to find and interpret the value of the ratio. So, in order to do that, I basically need to work this out, okay? So, what does that mean right there I have to do? I've got 3 halves, go ahead and write this, divided by 2. We've talked about this before, and here's just another way to write that. 3 halves divided by 2. Now, if I wanted to turn that 2 into a fraction, what would it be?
2 over 1.
2 over 1. Am I allowed to divide fractions?
Yes. No.
No, what do I have to do?
You have to switch the number.
What's that method called? KFC, keep, flip, change. So we keep the first one, we flip the, and we change the. Very good. Okay, now is there anything there that I can cross reduce? No, there is not. So I'm simply going to multiply across the numerator and then the denominator. Guys, what's my answer? 3/4. Okay, so 3/4 is the value of my ratio that I've come here to understand. But here's what it says. It says to find and interpret the value of the ratio. Remember when we wrote before, we gave a full sentence about what it meant to interpret something, okay? So I'm going to explain to you what it means to interpret this. This basically is saying the amount of cold water in the recipe is 3/4 the amount of glue. That's what that 3/4 right there means. So we're going to go ahead and write this down. Okay, so once again, it's asking us interpret the value of the ratio, and when we got that 3/4 right there, we understood that the amount of cold water is 3/4 the amount of glue that I have in that recipe. So the next vocab words we're going to have today are equivalent ratios. This just means two ratios that describe the same exact kind of relationship. All right, equivalent. What word do we think of when we hear equivalent? Equal, all right? So these are going to be two ratios that equal each other. So here I've got 1/2 equals 2/4. Can anyone else think of another fraction that also equals 1/2? Charbel, what's another one?
6/12.
6/12, very good, because 6 is exactly half of 12. What's another one, Taylor? 50 over 100. Another one, last one, Brody. 3/6. Okay, very good. So all of those are equivalent ratios because they equal each other. They each equal 1/2. So for the next section, this says find the missing values in the ratio table and then write the equivalent ratios. So we're going to understand equivalent ratios means two things that you can compare to each other that are equal to each other. So you can organize equivalent ratios in a table. Here's what I want you to understand. Anytime that you go from a top value to a bottom value in this kind of an equivalent ratio table, that means you're going to divide. So now you can imagine if I were to start on the bottom and go up to the top, what's the opposite of divide? Multiply. So if I'm going from the bottom to the top, I'm going to have to multiply. Okay, so basically here, this ratio table, it's a combination of a bunch of different equivalent ratios, ratios that are equal or equivalent to each other. The first thing I need to do is figure out what the value of the ratio is. And the way I can do that is I can take this number I have on top and divide by the number on bottom. Guys, what's 18 divided by 3? 6. So the value of this ratio is 6. Go ahead and put that in right there. Now, if that's the value of the ratio for that, and I know the whole table is equivalent, I can simply take that value and put it in for each and every one of these. Okay, so that's the value of my ratio. Now we've got to see, I have a number down here at the bottom, but I am trying to get up here to the top. When I'm going from the bottom to the top, do I multiply or divide? I'm going to multiply. So what's 5 times 6? 30. That means when the y is 5, then my x will be 30. Next up, I am going from this 42, and I'm trying to get down here to figure out what my y would be. What would y be?
7.
How'd you figure that out? You divided. 42 divided by 6 equals 7. Now finally, I've got to figure out what my x is. How do I get from this 4 up to the top?
Multiply.
And what do I get?
24.
24 is correct. So now what you've done here is you have found the missing values, but there's something else that it asks me to do. It says, then write the equivalent ratios. Remember, equivalent ratios are ratios that equal each other, like 1/2, and then 3/6, and then whatever number you guys said, 50, hundreds, lots of different ones, okay? So now we're going to go ahead and just write this. 18 to 3 was the first one. Then put a comma. Next up, what's my ratio here, the equivalent ratio? 30 to 5. What's the next one?
42 to 7.
42 to 7. And the final one?
24 to 4.
24 to 4. Now, when we're doing that, we're not using the value of the ratio as part of our answer, but it helped us. It was like the missing link that helped us to figure out what my equivalent ratios were. For the next one, we've got a certain number of cups of liquid versus the certain number of quarts of liquid. Remember, if I am going from a top number to a bottom number, what sign do I do? I'm going to divide, and the opposite is true when I am going from the bottom to the top. I have to Multiply. So as you can see, I know cups and quarts in this one. How do I get from that 3 down to the 3/4? Which sign? I'm going to divide. So let's go ahead and just do some work right here. We're going to do 3 divided by 3/4. When I do that, remember there's another way that I can write that. 3 divided by 3/4. What should I do to that first 3? What number can go underneath it? Over a 1. Okay? Am I allowed to divide fractions? No, so we got to use KFC. What would this be when I do KFC?
3 over 1 multiplied by 4 over 2.
Excellent. Is there anything I can cross reduce?
Yes.
Which ones? Okay, so what does my answer become? 4 over 1, which is just 4. So right here, what you've just learned is that 4 is the value of the ratio. So if I put this as 4 is the value of the ratio here, remember what I need to do to the rest of the table?
The more is 4.
It is all going to be 4. Everything, the value of the ratio is 4. So now let's see if we can figure out how to fill these in. Does anyone know what this ratio right here, what the quarts would be?
3.
What would it be?
3.
3. How'd you figure that out?
You divide it by 12.
Okay, 12 divided by 4 when you're going down here equals 3. Let's go on to the next one. Do I need to multiply or divide when going down? Divide. So I'm dividing 15 divided by 4. Listen, you could put it in here as an improper fraction, okay? Especially you can look right here. This one is already improper, okay? So I'm okay if you leave it as 15/4. What else could you put it as? 3.75. For those who like mixed fractions, you could do 3 3/4. I'm really okay with you putting whatever you want in that part as long as it's equivalent to 15/4. Now I've got to figure out how to get from 5/4 up to the top. To figure out 5/4 quarts is how many cups? How would I do that if I'm going from the bottom to the top? Multiply. All right, so we're probably going to need to do a little work over here. 5/4 times 4. Can I cross reduce anything?
Yes.
All right, and what do I get for my answer?
5.
5. All right, this equals 5, so we're going to go ahead and put our 5 right up here. Now that's not all it asks us to do. It asks us then to go ahead and write the equivalent ratios. So let's look at this first one. Remember, we can basically take out the value of the ratio when we're writing the equivalent ratios. The first one is 3 to 3/4. What's the next one, Brody?
12.
12 to,
3.
good job. Alexis, what's the next one? Okay, she had put 3.75 for me. I'll go ahead and put 15/4 since mine was an improper fraction. And Sierra, what's the final one? 5 to 5/4. Okay, and that is your final answer right there because those are your equivalent ratios. All right, so the next one, we've got kilometers and hours, things that we're just kind of comparing here. Maybe the speed of how fast someone is going, okay? So once again, just remind me, if I'm going from top to bottom, what do I use?
Instead of hours.
Okay, so this might be comparing how fast somebody is going. Here's what I want you to do with your partner is try to figure out what the value of the ratio is between those two. Okay, so once again, remember, when you're going downward, you're dividing. When you're going up, you're multiplying. All right, I would say about half of you guys got the correct answer. So here's the deal. If I am going from the top to the bottom, what do?
You divide.
I am dividing, okay? So this is going to be 5/2 divided by 4 over 1, which means I have to KFC. A lot of people forgot to do their KFC, okay? If you remembered, what's the value of the ratio? 5/8, okay? So once you've figured out that the value of the ratio is 5/8, that is the value of the ratio for the entire chart. Now I want you to try to fill in the missing values for the kilometers and the hours. For this next one, guys, we have the bottom one, but we've got to get up to the top. So what sign am I going to do? Guys, if I'm working from the bottom to the top, what am I doing? Multiplying. So I'm going to take 16 over 1 and multiply it by 5/8. Does anything cross-reduce? Yes, this becomes a 1 and a 2, and what's my answer?
10.
10. So I'm going to go ahead and put my 10 up here. That's 10 kilometers per hour. Now I'm going from 5 up here on top down there. When I'm going from top to bottom, what do? You divide. So I'm going to take 5 divided by 5/8, the value of my ratio, which means 5 times 8/5. Can anything cross-reduce? Yes, so cross it out. What do you get, guys? 8. All right. Was there anyone who got both of those correct when you did it with your partner? Excellent. Now, final answer. It does ask us to fill in the table, but now it asks us to write the equivalent ratios. Charbel, what's my first equivalent ratio in this table?
2/4.
Okay, the first one is 5/2 to 4. Cameron, what's the next thing when I am comparing right here?
10 to 16.
10 to 16. And Javaria, what's the last one? 5 to 8 is correct. So those are my equivalent ratios. And once again, remember, the value of the ratio is the missing link that helps me to figure out what all the other equivalent ratios are. For this next problem, it says you mix 2/3 teaspoon of baking soda with 3 teaspoons of salt. Find and interpret the value of the ratio of baking soda to salt. Remember, whenever we are doing this, we take the first ratio, 2/3 teaspoon of baking soda. We write that down first because it came first, okay? So that makes sense, 2/3. And then, remember, I am going to compare it with 3 teaspoons of salt. So there's multiple ways that I can do this. Remember how we said we could do 2/3 to 3? I could do 2/3 to 3. What was the last way that I said?
2/3 is divided by 3.
2/3 divided by 3. So that's the thing that I really want us to focus on. 2/3 divided by 3. Remember, when I've got this, this simply means 2/3 divided by 3, which means 3/1. Now I KFC it, 2/3, flip the second one, and change the sign. Does that make sense? Are you following how we just did that?
Yeah.
Okay, so you are always going to divide the first thing that it says in your problem by the second thing. What is 2/3 times 1/3? 2 ninths. Now what it has asked us is find and interpret. So we need to understand what in the world does that 2 ninths mean. I want you to talk to your partner and see if you guys can figure out or interpret what that 2 ninths means. Okay, we are definitely on the right path there. He started off with saying the amount of baking soda. So let's go ahead and at least write that part down. Okay, so once again, we know that we're talking about the amount of baking soda because it came first in the problem. So we're going to put that first in our answer when we are interpreting it. Who wants to help me from here? What else does this mean? The amount of baking soda. That is exactly correct. The amount of baking soda is 2 ninths the amount of salt. Okay, so once again, the way that you understand this, the amount of baking soda was first in the original problem, is 2 ninths the amount of salt. Salt is the second thing we talked about in the original problem. So that helps you to know when you're interpreting it, how to figure out which one goes first. And then this right here, the value of your ratio, helps us to know how we're comparing it. This next problem says to find the missing values in the ratio table, then write the equivalent ratios. That's super similar to what we have done on the previous tables today, but there's one thing that's missing on this table from all the other ones. What is missing on this one? What is it, guys? The value of the ratio. All of your homework problems tonight are not going to have that little line in there that says the value of the ratio. I put that in there to help you guys understand you have to find the value of the ratio first, okay? So now what I want you to do, you'll see the instructions up on top, but the original problem here is this table. Does everyone see that? So tonight on your homework, when you're doing your homework, you need to write the original problem. That means you must write the table down as your original problem. I do not need you to write these instructions, okay? But I do need you to go ahead and write the original problem. So right now in your notes, I want you guys to write this original problem down for me, please. So once again, here we go. All right, we're trying to compare here calories to milk. All right, so the first one you can see here, it's done this part for us. 20 calories for 5 cups of milk. All right, to get from the top to the bottom, what do I do?
Divide.
You divide. How about going from bottom to top?
Multiply.
You multiply. Now, just by looking at this, is there anyone who can figure out what the value of the ratio is? What is it? How'd you figure that out?
Mental math.
Okay, 20 divided by 5 is 4. So remember what we talked about now. 4 is the value of the ratio for all of them. Okay, so now I want you to see if you guys can figure out what those 3 missing parts of our table are. All right, let's see what we came up with. Guys, if I have 3 cups of milk, how many calories would we say that is? 12. How'd you figure that out?
4 times 3.
Okay, if we remember, the little missing link right here is a 4. So 3 times 4, because I'm going up, would be 12. All right, excellent. Who got 12 for that one? Okay, let's go on to the next one. If I have 16 calories, how many cups of milk are we saying that is? How many?
64.
I heard 64 and I heard 4. Guys, if I'm going from a top number down to the bottom, do I multiply or divide? I divide, so it's going to get smaller. So what's my answer? 4. Remember, the main thing, we learned that the value of the ratio was 4, so 16 divided by 4 equals 4. Next up, the hardest one we have today is this one down here. I've started with a half a cup of milk, and I'm trying to figure out how many calories. What sign do I need to do to get up there? I've got to multiply. So I'm multiplying a half times the value of my ratio. What would that be? 2. So a half a cup of milk would only be 2 calories. Okay, how many of you were able to get that entire chart correct? So once again, tonight's homework is going to look exactly like this kind of a problem. It will not have that little missing box in here that I had helped you out with the value of the ratio. So you guys have to figure out what the value of the ratio is and then put in those pieces. But now the last thing it asks us to do is to write the equivalent ratios. So first up, 20 to what? 5. What's the next one? 12 to 3. Girls, what's the next one? 16 to 4. And boys, what's the final one? 2 to 1/2. So that's what your final answer is. Okay, so tonight's homework, as you're doing it, make sure you write out what all those equivalent or equal ratios are. Now, we've got about 7 minutes to be working through this.